Suppose a race car is driving on a circular racetrack and is constantly 5 feet from the center of the racetrack. The race car starts at the 9 o'clock position and travels counterclockwise. We'll let theta represent the radian measure of the angle that subtends the path the race car has traveled, and suppose we're concerned with the race car's horizontal distance to the right of the center of the racetrack. So we should definitely start by drawing a diagram. So we've got our circular racetrack, and in this scenario, things are a little different than usual. The race car starts up here at over here at the 9 o'clock position instead of the 3 o'clock position. And then the race car starts traveling counterclockwise along the circular ski trail. So we'll just kind of freeze the situation right there, and we'll draw in our angle. So initial ray points in the 9 o'clock direction, because that's where the race car started, and then terminal ray passes through the race car's current position. And so this right here, that is the angle that we're looking at, and theta represents that angle measure, which looks different than normal. It's a number of radians swept out from the 9 o'clock position and not the 3 o'clock position. So let's suppose we're concerned with the car's distance to the right of the center of the ski trail. I'm going to try to draw in some horizontal and vertical diameters there. And so we're concerned with this distance right here, the car's distance to the right of the center of the ski trail, or like that horizontal distance. So it's going to be tempting, based on what we've been doing so far, to say that this is cosine of theta radius lengths. But it turns out that is not true. When we input an angle measure into the sine or cosine functions, it's an angle measure swept out from the 3 o'clock position. Or in this case, theta is a number of radians swept out from the 9 o'clock position. So we've got a little bit of an issue here. What we want to input into the cosine function, so we'll erase that. What we want to put into the cosine function is the measure of this angle right here, the one that starts the 3 o'clock position and then sweeps out some number of radians and then ends up at that terminal ray right there. So whatever this is, I'm going to call this alpha, just for short. That the car's distance to the right of the center of the racetrack is going to be cosine of alpha radii, or 5 times cosine of alpha feet, because the radius of that radius of the circular track is 5 feet. So we can't leave this in terms of alpha because we don't know the value of alpha, and we're interested in expressing this in terms of theta. So how do we take a number of radians theta swept out from the 9 o'clock and turn it into a number of radians swept out from the 3 o'clock position? Well, if you think about this, think about starting at the 3 o'clock position over here, and then first rotate by pi radians. So if you imagine starting at 3 o'clock, and then you rotate pi radians, that gets us to the 9 o'clock position over there. It's half of a full rotation, so it takes us from the 3 o'clock position to the 9 o'clock position. And then, if you rotate another theta radians, that gets us to the terminal ray that passes through the car's current position. And therefore, that alpha, that number of radians swept up from the 3 o'clock, is actually equal to starting with pi radians rotated from the 3 o'clock, and then an additional theta radians swept out from that 9 o'clock. And therefore, when we see these alphas, we can think of this as just pi plus theta. So we can think of this as pi plus theta radians swept out from the 3 o'clock position. And again, we can think of that as starting at the 3 o'clock position, and then rotating pi radians, which puts us at the 9 o'clock position, and then rotating an additional theta radians from that 9 o'clock position, which gets us to where we want to be. And then as theta varies, this pi plus theta is going to vary accordingly, so that it always represents the number of radians swept out from the 3 o'clock position instead of the 9 o'clock position, which is something that we can use as the input to the cosine function.